let's get through these last few problems first. And then we'll do a practice ellipse problem in preparation for an ellipse quiz, which, let's see, you guys will be what, Thursday? All right, so here we go. We're on our notes, the back of page 57, and we are told, I'm just going to go ahead and sketch this instead of write it down. We're told that the major endpoints are -2, -3, and -2, -7. Okay, those are the major endpoints. And then it tells me that the minor axis is 4. Now, keep in mind, if those are the major endpoints, then doesn't my ellipse look like this? Is that right? Okay. My equation is going to look like this. That's what ellipse equations look like. And if you happen to forget that, look back at some of the earlier problems in the notes. The equations are written out in those problems so you can tell. That's what it has to look like. All right, so what are your thoughts? How are we going to get started on this? What do we need to know? I need to know the center because that's what goes in here, right? And if these are the endpoints of the major axis, doesn't it make sense that the center's in there somewhere? And not just anywhere, isn't it going to be right in the middle? Okay, so what would be right in the middle of these 2 points? You are on your graph paper. It should be so easy for you to find. Don't overcomplicate it. -2, comma, -5. That's the one right in the middle. -2, -5. Isn't it 2 units to here and 2 units to here? So, -2, -5 means x plus 2, y plus 5, right? Now, we kind of already found another number because if we knew we go up and down 2, then that means under the y, the up and down, is what number? 4. Because the square root of that number tells you how far up and down to go. So thinking backwards, if I go up and down 4, or excuse me, if I go up and down 2, then that number has to be a 4. Now I have no idea about sideways, but they tell me that the minor axis, right? Did I copy this right? Okay, they tell me that the minor axis is 4 units long. So what does that mean? That means I'm going back and forth 2, which means this is also a 4. Now this is kind of a wacky problem. This isn't actually an ellipse. What is this? A circle. Yeah, so that's my fault. I messed up. But that's right. From the information, that's right. Is that okay with everyone? All right, next we have foci. These are not vertices. These are foci at 1, -4, and 5, -4. And the major endpoints are 0, -4, and 6, -4. Now those are endpoints. So my ellipse is going to look like that. These points are endpoints. this is my major axis. Does that make sense? Okay, so we know what our equation looks like. Our equation is going to look just like this one. I can fill in all those blanks. So what do I need to know? Center. So won't the center be in the middle of all this? You've got your graph paper. You don't have to do any tricky formulas. You don't have to do anything. You can just kind of count. What point is right in the middle of all of this stuff?
3 and -4.
3, -4. Which means my equation is x minus 3, y plus 4. Right? Now, I need to know the numbers that go under here. Aren't these the numbers that tell me how far to go? Well, don't I already know how far to go this way? From my center to my vertex, this is my vertex. From my center to my vertex, how far is that?
3.
And if that's 3, then under x has to be a 9. Now, how did I know to put it under x? Because it's going sideways? This is a tricky one. I don't know what that is. I don't know. But I do know that from my center to my focus is how far? From my center to my focus is
3.
Center to focus is 2, isn't it? And how do we find the distance from the center to the focus in an ellipse? So we're looking back at our notes. What do? Subtract the denominators and take the square root. So subtract 9 minus n and take the square root. My denominators, subtract them. So the square root of 9 minus n has to be 2. Which means 9 minus n has to be 4 if I square both sides. So what's n? Yoo-hoo! 9 minus what is 4?
5.
There we go. That number is a 5. Now, I know that's not a perfect square, but it's no big deal because you're not graphing it, so don't worry about that. It turned out to be 5 for this equation. All right. What was that? That was h. All right, 2 more. There will be one problem like this on your test, not on your quiz, but on your test you will have a problem like this. So what's happening in I? -2, 1 is a focus. -2, 5 is a focus. And -2, -1 and -2, 7 are vertices, the endpoints of the major axis. So this is my major axis right there. Okay, Kendra, let's wake up. We need to write the equation of this ellipse. So we need the center. So my equation is going to look like they always look. Would everybody agree that your center is in here somewhere? Okay, so on your graph paper, you should be able to kind of figure that out pretty easily. You can always do the midpoint formula by averaging. But if you don't want to do that, you don't need to when you have a nice little graph like that. What point is right there in the middle? -2, comma 3. So -2, +3. There's my center. Now when you build this equation, this picture, how far up from the center and down from the center did we go? Up from the center and down from the center. How far did we go?
4.
We went, okay, did you check in with Mr. Frigie? You're on the tardy list, so you need to go check in with Mr. Frigie, quickly. See, talk to Mr. Frigie and come back, if you can, hopefully. So how far up and down did we go? 4, which means what in terms of the equation? 16, where? Under y, because we went up and down 4. The square root of this number is how far up and down we go. Okay? Now this is a tricky one, just like the last one. I have no idea what this is. They didn't give me any other information. So I have no idea how far sideways I'm supposed to go. What I do know is that the distance from my center to my focus is what? This is my center, this is my focus. What's that distance? 2. And I know that I find that distance by subtracting my denominators and taking the square root. This is hard, you gotta think backwards. Squaring both sides, 16 minus what is 4? 12. So this denominator is a 12. All right, one more of these. Then we'll look at what lights on the quiz. One more. Writing the equation. The major endpoints are 3, -7. Did you check in with Mr. Frigie?
I was talking about difficulty.
Okay, you need to go check in with Mr. Frigie and explain to him the situation. I'm sorry, that's the rule. All right, so those are the endpoints of my major axis. Okay, I don't know, it means that my ellipse looks like this, would you agree? And this is my major axis right here. My equation looks like all of them, it's like this. Do I have enough information to find my center? Yeah, because won't the center be right in the middle of this axis? So see if you can figure out what point that is, right here in the middle. I heard a 3, -2. Does everybody agree with that? So x minus, +3, yeah, x minus 3, y plus 2. And then look, how far up and down did we go? What's that distance? 5, which means under y is a 25? Now they told me that the minor axis is 6. that means that to graph this thing, I'm gonna count sideways 3, which means under x must be a 9, because the square root of that number tells you how far sideways to go. Okay, now the 8-2 homework is due on Thursday. And again, I think we talked about this yesterday, I stapled the pages wrong, so make sure you're in the 8-2 homework. You know what that means. Now, somewhere, maybe you have a piece of paper, you can get some lined paper over here, you got a scrap paper somewhere. I want to do an ellipse practice problem. So, go ahead and get a sheet of paper over there if you want, or pull out your own sheet of paper, your notebook, whatever. And we're going to do a practice ellipse problem, because we're going to have to do this on Thursday. Right, today's Tuesday. I don't see you tomorrow, so Thursday, okay? So here is the equation of an ellipse. X minus 2 squared over 16 plus y plus 5 squared over 9 equals 1. And your job is to find the center, the vertices, the length of the major, the length of the minor, and the foci. I think everybody gets the first 4 right. This one's a little trickier, but everybody gets the first 4 right. Thank you. Okay? Now, tell me about those first 4. You do not have to draw a graph. I will provide you with a graph, but you don't need one. It's to answer the questions. These are the answers, all right? So where's the center?
2, -5.
2, -5. Draw this a little bit. So the center's at 2, -5. All right, done, easy. How about vertices? Now remember, the vertices are the points that we connect. So tell me about those. How am I gonna find those? There's 4 of them. What? What do I do? I look at these numbers. And the square root of 16 is 4. And it's under x, so it's sideways. So I'm going to start right here, and I'm going to, on my graph paper, count over 1, 2, 3, 4. Where am I? What point is that on your graph paper? Oh, wait, you don't have graph paper either. Imagine it. Imaginary graph paper. That's -2, -5. And then 1, 2, 3, 4 this way would be 6, -5. So that's 2 of my vertices. And you can put these in any order. The order doesn't matter. And I'm going to go up and down 3 from here, from the center. So 1, 2, 3, 1, 2, 3. And let's see, if I go up 3, that's 2, -2. And 2, -8. Does that sound about right? So those are my other vertices. And so there's 4 of those. 4 of those. Now, major axis. That is, here are the axes of the ellipse. axes of the ellipse. The longest one is the major one, so that would be this one in this case. How long is it? Well, think about how you made it. Didn't we count back and forth 4? So it's 8. And that one up and down 3, that is 6. Now, that part is so easy. We can all do that part. Now, what about the foci? Well, the first thing is, where are they always located? Major axis. So, somewhere here are the foci. To know where they are, we know we're going to go, here's the center, we know we're going to go right and left. We need to know how far to go right and left. How do we find how far it is from the center to the focus? How do we find out how far that is in an ellipse? 16 minus 9 square rooted. This is almost always a radical, so you're just going to have to deal with it. It's possible to not be a radical, but it almost always is. So, that means I'm going to start right here, and I'm going to add root 7. I'm going to go root 7 that way. Okay, so where am I starting? At 2? So this point right here is 2 plus root 7, comma negative 5. Why am I adding the root 7 to the 2? Because I'm going sideways, which is x. And then what's this one right here going to be? So this one, guys, was starting at
Negative
2
minus
it was positive 2 plus root 7, because I went to the right. So if I go to the left, thank you, it's 2 minus root 7. So if you're doing this on graph paper, I'm not going up and down, so my negative 5s are all staying the same. It's staying negative 5. But my x's are changing. 2 plus root 7, 2 minus root 7. Okay? If we have time at the end of the period, we will do another one of those, but that's exactly what your quiz is going to look like tomorrow. I'm going to give you an equation just like that, and you'll give me all this information right here. Okay, and we have one more conic section, and that is the hyperbola. Tomorrow's quiz is over the ellipse. The equation just like this. You're going to find that information. Hopefully you wrote that down so you can go back and look at it. Would somebody read me, or maybe you haven't memorized, what was your definition of an ellipse? It's in your notes, or should be. We talked. We should write it down. I know it's a set of points in a plane. They all start that way. Set of points in a plane. Okay. What is the ellipse definition, Jacob?
Set of points on a plane where the sum of these two fixed points is consistent.
Yeah. So it's an ellipse. This is an ellipse. Set of points in a plane. The sum, S-U-M, adding. The sum of whose distances from two fixed points is constant. That's the definition of an ellipse. The definition of a hyperbola is exactly the same, except set of points in a plane, the difference of whose distances two fixed points is constant. So these two definitions are exactly the same, except an ellipse, that's a sum, and a hyperbola, that word is a difference. These two fixed points are still called the foci, just like they are with an ellipse. Okay, got the definition? So, for ellipse, it's word for word, exactly the same, except in an ellipse, that is SUM. In a hyperbola, it's difference. Now, I think you'll see when we look at the equation. Look at the first equation. Does this look like the equation of an ellipse? Well, what's different about it?
Subtraction.
In an ellipse, that's a plus, which is sum. In a hyperbola, it's a minus, which is difference. But everything we do pretty much is the same. So, tell me where you think the center of this is. The origin. Why is the center of the origin? There's no parentheses, right? 0, 0. So there's your center. What does that 16 tell us? Sideways 4. So 1, 2, 3, 4. And what does that 2 tell me? Up and down 2. Now, here's where we start being different. So far, is this exactly what we do with an ellipse? Yep, no difference. Here's where it's different. With an ellipse, you join those points and make a nice little oval. With a hyperbola, and you know it's a hyperbola because it's got a minus. With a hyperbola, you draw a rectangle through those points. Okay, so when it's a hyperbola, you draw a rectangle. Now, once you get the rectangle drawn, as carefully as you can, I want you to draw in the diagonals of that rectangle. These are supposed to be straight lines. That does not even look close. And I'm putting them dashed. You can certainly make them solid if you wish. It doesn't matter. But draw in the diagonals of the rectangle. Now, whatever letter comes first in the equation, in this case it's X, I want you to go back to your picture, and I want you to make the X vertices. Remember, you counted sideways 4 and up and down 2. So you really have these 4 points. Whatever one comes first, whatever letter comes first in the equation, I want you to make those points a little bit bigger. And then I want you to draw in a curve on each side. And that is your hyperbola. So the hyperbola is like 2 matching parabolas going opposite ways. Does it make sense to you that I could have drawn in these big fat ones, the top and bottom ones. You only draw the top and bottom if in your equation the y comes first. In this equation, the x comes first, and I always use those vertices, the x vertices, to open my parabola. Okay? So, let's write down what we know so far. We know the center, 0, 0. And we know our vertices are 4, 0 and negative 4, 0. These 2 points are not vertices of the curve. Does the curve, this is the curve, the black parabolas are the curve. Does the curve go through those points? No. Now, I use those points to draw my graph, but they're not vertices. A hyperbola has only 2. Okay, on your test, I will help you out with that. In the answer blank, I will have just 2 parentheses for you to fill in. For ellipse, there's 4. Okay, now when you built this box, this rectangle, it is longer this way than it is this way, agreed? In ellipse vocabulary, that is called major and minor. In hyperbola vocabulary, it is called transverse and conjugate. Now, in the word transverse, see that V-E-R? Vertices. The transverse axis joins the vertices. So how far is it? This is a vertex and this is a vertex. How far is it from vertex to vertex? 8. The other direction of the box is the conjugate axis. How long is that? 4. Foci and the equations of the asymptotes. Let's do the equations of the asymptotes first. Would you agree that the asymptotes are lines? Yes, they're lines. And what do we need to write the equation of a line? Point. So I want you to look at both of these lines. There are lots of points you can figure out, but what point do you know for absolute sure is on both of those lines? Which point's on both of them? The center. In this case, it happens to be 0, 0, but it could be something else. The center is always going to be where they cross, so we're going to use the center as our point. So our point is 0, 0. What's our slope? Let's think about this for a minute. Don't I need to get from this point to this point, for example? How far up do I go? How far over do I go? What's the slope of that line? 2/4 or 1/2. That's exactly right. Now, what if I went in the other direction? What if I did this line? I'm still going up 2, but now I'm going left 4, so that slope would be -1/2. One direction it's positive, one direction it's negative. So the slope of this line is up 2 over 4 or up to left 4. Remember how to write the equation of a line? Y minus the y coordinate equals m minus y equals m, I'm using positive 1/2. I have to do two separate lines. X minus 0, so that's just y equals 1/2 x, isn't it? And then I'll repeat using negative 1/2. I think that one's just, since those are zeros, that one's just negative 1/2 x. There are the equations of my asymptotes. Hyperbolas are the most involved. They're the toughest for sure. Okay, one more thing to find. Anybody want to take a wild guess? Just generally speaking, where are the foci located? Like, is there a focus up here? Where do you think the focus points are? Jacob?
Probably inside the
Exactly. Right, exactly where they always are. They're inside the curve. So isn't there going to be a focus here and a focus here? Yep, that's where they are. Always, always measure from the center. It's tempting to measure from a vertex, but you don't. It's always the center. Okay, now let's stop a minute. Your quiz next time is an ellipse. How do we find the distance from the center to the focus in an ellipse? What do we do in an ellipse? Subtract the denominators and take the square root. Guess what we do with a hyperbola? We add them. We add them. So it's 16 plus 4. Which is 20. And the square root of 20 is 2 root 5. Please take very careful notes. This is a little bit, it's a lot. There's just a lot. I want you to have really good notes. Okay, RJ? RJ? Oops, RJ? You feeling okay? Someday I hope you're all alpha period math teachers, so that you can experience this. All right, here we go. I have added my denominators and taken the square root, and I got 2 root 5. That means that from this point, which is 0, 0, to this point, I'm going to add 2 root 5. So this point is going to be 0 plus 2 root 5, comma 0, and this one is 0 minus 2 root 5, comma 0. And those are our foci. A lot of that is just like the ellipse, but there are a few differences that we need to keep track of. Let's see if we can fight through one more, and then we'll stop and answer some questions if you can think of anything that you're just wondering a little bit about. Let's try one more equation, the next one. Okay, let's see how much we can get right. What is our center? 0, 0. And how do we know that? There are not any parentheses, and that's true for every one of your shapes. Circles, parabolas, ellipse, hyperbola. If there's no parentheses, then you're starting at the origin. So we're starting at the origin. Okay, what does the 9 tell me? Be careful. What does the 9 tell me? Go up and down 3. So why am I going up and down? Because it's under the Y. You have to pay attention to what letter it's under. Whatever letter it's under, that's the direction you go. What does the 16 tell me?
Maybe 4. Or
Left and right, 4. On our quiz, when we have an ellipse and we get to this point, we're going to connect them with an oval. But this is not an ellipse, this is a hyperbola. So we have exactly the same points, but we build a box. So through your 4 points, you build a box. Okay, then what? What do we draw into that box? The diagonals, yeah. These are going to become the asymptotes of the picture. Right, everybody okay with that? Now, you're going to draw in your shape now. And remember, your shape is either this or this, right? And to tell which one it is, you look right here. It's very simple. What letter's first? Y. So this guy is opening, this is a vertex. He's opening up and down. So your vertices, there's only 2 of them, are 0, 3, and 0, negative 3. Your vertices are that turning point of the curve. They're right on the box. Now there's 2 axes. There's 2 axes in this problem, just like there are in an ellipse. With a hyperbola, it doesn't have anything to do with length, it has to do with which one contains the vertices. So, transverse. Here are the vertices. This is the transverse axis. Vertex to vertex. How long is it? 6. So the transverse axis is 6. The other axis, not this one, this one is the conjugate, and it is 8. These dashed blue lines are my asymptotes. They're like containing the curve. What is the slope?
3
1, 2, 3. 1, 2, 3, 4. So the slope of this line is 3/4. Rise over run, up over over. What about this one? Same thing, only it will be negative 3/4. Now to write the equation, you need the slope, got it? But you also need a point. What point are you always going to know? Well, in this case, it's the origin. It will always be the center. So, y minus y equals slope x minus x. Your point is the origin, your slope is 3/4. I'm doing the positive one first. Now, normally we have to do a lot of cleanup work there, but because those are zeros, isn't it just y equals 3/4 x? Because they're zeros, it's easier. And then we do the same thing with the other slope, which is negative 3/4. Isn't that just negative 3/4 x? Now, obviously, when the center is the origin, things are easier than it is when they're not, but right now, let's enjoy the easiness of having all these zeros. All right, last thing, and then we'll do another practice problem for your ellipse. This is the last thing. I need to find my foci. All right, so first of all, visualize where they are. Where are they this time? Up here and down here? So we need to know, here's my center. I need to know what that distance is from the center. This one's easy. How do I find that distance from the center to the focus? In a hyperbola,
64.
I add my denominators and take the square root. So this one worked out nice. Normally they don't. This one did. So this distance is 5. What point is that then? If I start at the origin, my center, and go straight up 5. 0 to 5. And straight down 5. Wonderful. Hyperbolas are hard. Hopefully you've taken very, very careful notes. All right, we'll work on that some more next time. Anybody have a question about that problem? Anything I did with hyperbolas? Okay, try to hang in. We're going to do one more practice problem and then we'll be done. Everybody good? Okay, so let's do an ellipse problem. So get out your scrap piece of paper or get a sheet of paper over there or something. And let's work through one more ellipse problem. So you're going to get a half a sheet of paper where we take our quiz. You're going to have an equation. Find the center, the vertices, the length of the major, the length of the minor, and the foci. There will be 4 of these, 1 of these, of course, and 2 of these. So we have to find all that stuff. Kayla, you want to practice with us? All right, so here we go. What do we know right off the bat? Center is 3-1. Nobody's grading your picture. What's getting graded is this right here. That's your center. Gio? So, wait, I'm going to go left and right. How far?
Y, on the y-axis, we go 3. We go left and right, it'll be 6, y. We go 4.
I'm not under understand. What, tell me again? I mean, I'm just not clear on what you're saying. You want me to go up and down, how far?
Left and right,
Left and right, how far?
6, but it would be 3, left and right.
Okay, now wait a second. X is my left and right number, right? And under the X is a 16. Square root of 16 is 4. That's how far left and right I'm going. 1, 2, 3, 4. 1, 2, 3, 4. These 2 points are 2 of these, okay? So if I start here at my center and I back up 4, count over 4, where do I end up? Negative 1, 1. And if I count forward 4, 3, 4, 5, 6, 7, 1. Now, that number's a 36. Square root of 36 is 6. It's under Y, so I'm going to go up and down 6 from here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm starting right here at 1, 2, 3, 4, 5, 6, 7. 3, 7. 0, negative 1, negative 2, negative 3, negative 4, negative 5, 3, negative 5. This is an ellipse, so I'm going to go ahead and connect those points with a nice oval. Oops, I got my other points over here. I have this axis and this axis for my ellipse. Which one's longer? This one? How long is it? Remember how you built it. You counted up and down 6, so it's 12. And then we went sideways 4, so it's 8. So far, so good, right? Gio, we got you straightened out back there? Okay. Where are my foci going to be? Always on the major axis, which for us is this one, so they're up here somewhere. I don't know where they're on there somewhere. I know where they are if I can figure out that distance right there. The center to the focus in an ellipse is the square root of 36 minus 16, which is the square root of 20, which is 2 root 5. So you put your little pencil right there, and you go straight up 2 root 5. Well, where are you? How high are you starting already? At 1? So you're going to do 1 plus 2 root 5 and 1 minus 2 root 5. So this point is 3 comma 1 minus 2 root 5. And this one is 3 comma 1 plus 2 root 5. Start at your center and add your distance and subtract your distance. Done. That's what our quiz, and those 2 blue points are. So that's what our quiz on SNSC is going to be. Okay, Kate, you never did make it in today? Alright. Maury and Kaylor. Kaylor, you guys haven't done your senior survey yet? The survey Mrs. Babanka keeps emailing you about? So sometime today, maybe you go right now, you go to Mrs. Babanka's office, and she, or a classroom thing, and she will help you get that done, okay? I don't know, you haven't done it, you're on the list, so you need to go see Mrs. Babanka.
I was talking about it yesterday.
Okay, no, you didn't, she gave me this list this morning.
I know, I was talking to her.
Okay, you need to talk to her today and get it done, okay? So you and you are ready to go get this taken care of, right? You don't want to have to miss another class today to get it done. All right. Have a good day. See ya, couple days.
On the other hand, that dude, I don't know,
Okay. Pickleball's postponed, okay. Big pizza, coffee and donuts. I need to take attendance and it was a disaster. Okay, so let's take attendance. For Alpha period, roll without me. Greg was out. Jeff Keith was tired. Boston was fine. Caius was tired. Ayrton was here. Taylor was tired. Josh was asleep. Archie was out. Edwin was tired. Joe was tired. It was purple, and I couldn't even all right, hopefully we don't have as many tardies as we had last period. Oh, yeah. Xavier, you need to see Mrs. Pavanka today. Mrs. Pavanka. Don't do that, because if you don't get this taken care of today, they're pulling you out of math class to get it done. You can't afford that, okay? Find her today sometime and get it done. Sandy Bridges, same thing. No, I'm not arguing. You're on her list. You need to see Mrs. Pavanka today. She will sit down with you and you'll get it done, okay?
I think I just messed it up. I got
And that could very well be that you need to do it. Who else do I have in this group? You need to see Mrs. Pavanka today and get that survey done. Okay? So find her today. Anytime, I don't care. Find her today. Honey, I don't know if there's any extras back there. It's all in storages. You can always print it from storage. All right, so here we go. It's time to start. Let's see where we are in terms of attendance. We have a very busy day today. We want to, oh shoot, I think I forgot to turn that video off, so it's gonna be a little extra long.